but it is slightly unexpected to me to see it segfault upon continuing. One would hope that when continuing, the trap would be simply passed on to the program by LLDB. Sure, get rid of a flag. Why not? This shouldn't make a difference at all, but when you don't have a solid grasp on what you're modifying, you just start changing stuff and seeing what happens. And although I would like to understand all of this a lot better, the reality is that I really don't know if this is going to work at all, and I don't want to spend a lot of time digging into exactly how this works for what is exploratory proof of concept. Like the amount of effort to understand everything that's going on here, it'll take a while. And I don't even know if it's going to work. So I'm just trying to see if it'll work first. Here I'm wondering if I need to set more of these frame parameters, because where we're having the crash is basically sending the frame. So it seems like something is wrong in the frame. And I skipped over a lot of these parameters, and so I'm trying to quickly go through and see either can I set it to something sensible, or does it look like I actually have to set it to get a valid result. And this definitely feels like a memory corruption bug. It's hard to really pin down exactly why, but some of the key things to look at is the fact that where most of this is just making up objects in memory that are usually handled for us. That's a good way to get memory corruption, is making your own memory when usually it happens behind the scenes. Another thing is that the symptoms we see are a bit all over the place, which definitely leans more towards memory corruption than, I don't know, logic bug, for instance, although they can go hand in hand at times. So now I'm going to try to finally look into what the pixels should actually look like. So far, we just did a best effort guess of, hey, here's a bunch of pixels. Please don't crash. Unfortunately, it is crashing, so we need to figure out what the pixels are meant to actually look like. Yeah, I'm slowly cottoning onto this planar part. I encountered this with audio, the planar audio, when you have multiple channels. But it took me probably much longer than it should have to cotton on to what the green, blue, red planar format was. I think I was very in the headspace of expecting just RGBA to be a thing that I could do. But it doesn't look like it is, at least in this codec. So I was a little bit biased by what I guess what I wanted to work. This guy just complaining about how some program he's familiar with is easier for him to use than some program he's not familiar with. Wow, I didn't catch this. You added it to After Effects. Wow. This guy is complaining about how it's easier for him to use something that he personally added to After Effects. Is that how I interpret this? That's really interesting. That I get a little bit more interested in who this guy is. But also I think because the reply mentioned another thread that had to do with RGB. So I was trying to find that thread. Logarithm is an encoder. Looks like it. It's not clear to me what logarithm is, but it's very clear to that guy what it is, apparently. Yes. The time of the video where we start reading the ffmpeg codebase. That's how you know we're in true prototyping mode, when we have to dig into the code itself. So there's a couple of AV1 parsers in ffmpeg, and this one is alphabetically first, but not actually the one that we're using. So this is a little bit of a detour. But nevertheless, the AV1 format supports GBRP. So either of them should have been sufficient to learn more about what that format is. And there's libaom encoder, which is what we're actually using. Okay, I'm getting pretty close to my discovering of the fact that my audio is busted. It should be less than a minute now. And when I discover that and re-kick off the recording for the third, well, re-kick it off for the second time, I guess, but start the third recording, I'll switch back over from this interlude to that. See, I'm trying to learn more about the format, but as you can see here, there's not really much in this code that tells me what the pixels actually need to look like, what the bytes themselves are meant to look like. So I'm trying to chase down this image format parameter that gets passed around to a bunch of places. Oh, and here's the discovery. So time to hand back.